like to ask quick questions and ask you all to give brief responses if you could, just to get through all these kinds of comments. But first of all, what are the practical consequences of, or practical applications of gravitational waves? Dr. Grimm, any thoughts on that?
Detecting gravitational waves is this fundamentally inspiring scientific problem. And the point that David was just making about a new window on the universe, instead of just looking in the electromagnetic region or just looking at particles from space, we now can look at, we can now look in a completely different way and see new things. But the practical consequences of doing this are really what Gabby was talking about. They have to do with workforce and they have to do with technology. There are miracles of vibration isolation and none of us really believe they're miracles, but they are remarkable efforts at vibration isolation, laser stabilization. All of those are spinning forward into technologies that are extremely important to the country. In addition, the students, and I was very impressed with your list, Gabby, the students that come out of this are not just doing gravitational wave physics. Right. They are going on and transforming the semiconductor industry and SpaceX and many, many areas.
Thank you, Dr. Grimm. You gave several examples. Any other examples anyone wants to mention? Dr. Reitze?
So I'll follow up a little bit. I actually believe what Dr. Crim said, that fundamentally LIGO is about opening a new window in the universe. Just to give you an example, after we announced our discovery, the amount of reaction to it worldwide was awe-inspiring. I learned yesterday that I'm not a social media person, but young people are. There were 70 million tweets about this discovery, which is, to me, mind-boggling. I can focus a little bit on the technology to focus on some of the vibration isolation system. We can't talk about it, but we've been approached by companies that manufacture computer chips that do lithography, and the vibration isolation that we do, all right, because we have such good low-frequency vibration isolation, we keep things still for a long time. That's actually something that could be very, very beneficial for companies that make semiconductor chips. There are other examples, too, that I could talk about, but maybe...
Okay. Anyone, Dr. González, anything to add? Dr. Shoemaker, then?
I have one thing I can add to that. Timekeeping is really important in a broad range of activities. I think GPS is one of the things that we most frequently use now, take for granted. It requires general relativity to work, but it also requires very precise timekeeping. And some of the innovations that we've made, both in laser stabilization, as well as these mirror coatings that are low loss and low noise, they help us do a better job of timekeeping, and that really makes a lot of the economy turn, being able to get things to place in time.
Dr. Reitze, let me follow up real quickly. And it is this: what can we learn from the LIGO detector? And you mentioned this briefly in your opening statement. What can we learn from the LIGO detector that we can't learn from traditional telescopes?
Well, gravitational waves are dark. They're invisible to the electromagnetic spectrum. So everything we know about the universe comes from X-rays or gamma rays or light or infrared radiation. This is a completely new sector. So in some sense, it's the complete complement of astronomy. And the event we saw, black holes, we believe that you can't see them using conventional astronomy. So that's one example. As David mentioned, cosmic strings. There are a whole host of things that you cannot learn from any other type of astronomy that you can only learn from gravitational waves.
I probably only have time for one more question, and let me address it to Dr. Shoemaker, Dr. González, and Dr. Grimm as well, and that is, for instance, Dr. Shoemaker, you mentioned coming surprises. Dr. González, Dr. Grimm both mentioned the future. So my two-word question is, what's next?
I'll make a guess, and it's a bit of a hope as well, that it will be a pair of neutron stars spiraling into each other, which we may actually see also with our ground instruments. That would be very exciting.
Great, thank you. Dr. González.
Let me mention that this discovery of black holes was a surprise. We didn't know that these objects were in abundance out there, and we will now know a lot more about those. So this was the first surprise. We expect other surprises.
You might discover something you're not even expecting.
That's
probably
right.
So.
Absolutely.
Dr. Grimm.
Your last comment is exactly the point. At the budget presentation, the director of the National Science Foundation, Dr. Cordova, said she wanted to tell us what the next discovery was, but she didn't know because we had to discover it. And I think that is a very important point. Now we have a completely new way to look. I mean, to get out of the electromagnetic spectrum and have the complement of gravitational wave astronomy is remarkable.
Great. Thank you all for your responses. The NSF is well represented here today, so I'm glad for them to hear your comments as well. Now recognize the gentleman from Virginia, Mr. Byer, for his comments.